Hello everyone and welcome to my channel. My name is Dr. Kurachi and in this video we're going to talk about hacking wireless networks. By the end of this module, you should be able to explain the wireless technology, what is wireless networking standards, and what is the process of authentication, where driving, and the different type of tools used by hackers and security professionals. Now, we know, wireless technology is part of our daily life. You will see it in a different type of system all over, you know. Now, there are few basic components here. We have the wireless network interface cards, which is, you could see it in this picture right here, which can transmit and receive signals. And we could have like our own access point and, and could be like built into existing router and the switch all built into it. And it can basically use it to bridge between wired and wireless networks. Now, also it needs RF spectrum, and part of our RF spectrum are applied for the wireless technology we use at home. However, there are different type of RF spectrum, which can range from very low frequency, like from 3 hertz to 30 kilohertz, application, navigation, submarine communication, long range, weather forecasting, and the propagation ground wave. And there's the low frequency one, and here you can see the range, medium frequency from 300K to 3 mega, and here we have the high frequency, 3 megahertz to 30 megahertz. You could see it like, in shortwave broadcasting, radar, air navigation, and we have very high frequency, from 30 megahertz to 300 megahertz. You could see it like an FM radio, up to extremely high frequency, 30 gigahertz to 300 gigahertz application like satellite communication, radar, medical imaging, propagation, line of sight. So there are wide range of frequency there. Now, it is important to note that the propagation characteristics of each one of these band impact their effective range and usability. Now, as you go higher and higher in frequency, the wavelength becomes shorter and the signal becomes more susceptible to abstraction and weather condition. On the other hand, the lower frequency, as you see it over here, you know, basically it can range to, it has a higher range of distance. Now, another component is the access point here, radio transceiver that connects to a network via Ethernet card. We have it at home, everywhere. You could link a wireless LAN to a wired network, as you see over here. Here we have the access point is connected through a wired to your switch. Okay. Now, not all connect to a wired network, the role of access point is basically to bridge the wireless LAN over here with the wired network. Some access point operate in the mode that do not involve a wired network like this one you see over here. For example, like access point could be a repeater or mesh mode, extend the wireless coverage without a direct wired link, and you can also always see those wireless repeater. Now, however, most companies or enterprises, they use wireless LAN connected to the company wired network, that's very typical. Now, point where RF channel are configured. Okay. Uh, this means that access points are basically the central configuration point for managing the RF channels in the wireless LAN. You know, as you know, the administrators can set the channel bandwidth, the transmission power to optimize the network performance and reduce interference. Now, also, the access point enable users to connect to the LAN, as I explained, and only available within a defined area, which means that the wireless coverage provided by this access point is limited to a specific area. They call it a coverage cell or coverage area. This is why, like, if you have a big home, you're going to end up having multiple access points, and keep in mind this coverage area is based on the size and the shape of the area, depend on different factors, like including the transmission power of the access point, any physical environments like walls, buildings, trees, that all can interfere with the signal. Now, in this picture here, you can see there are many tools like V-Stumbler. Here you could see that it captured all the SSID, and here you can see that this access point is active, and here you can see the MAC address and the name of the network and the signal strength, and the RSSI, which stands for the Received Signal Strength Indicator. You know, it's a metric used in wireless communication to present the power level being received by the antenna, of the device that you're using the software, to gather information about the available wireless network here. Now, a high one, like you see over here, this is a high one, indicates that the received signal strength is high, which, implies that could be a closer proximity to the wireless source between the transmitter and the receiver. Now, SSID stands for Service Set Identifier, which is basically identifier wireless LAN. It has a unique one up to 32 character alphabetical name, and that's, it means network name, case sensitive, and the wireless devices scan for available SSID broadcasts by the access points or routers, which, many routers has built into access point. Visibility, there are two types here. There's the broadcast SSID, there's the hidden SSID. By default, most of them are set to broadcast SSID, make it visible to anybody who wants to connect to your wireless network. Now, you could hide it, okay, by turning off the SSID broadcast, okay, but it's not a security measure for determined hackers, by the way. Now, in this picture here, you could see that to access the wireless, LAN, the access, you just have to click on a connect here, and basically you need to type, the passcode for it, and here you could see that this access point is broadcasting the SSID, by the way, like several times in a second, so your laptop has a wireless network card, you could connect to it if you have the right passcode. Now, there are many vendors out there. Many have SSID set to default value that companies never change, or users as well at home. As a security professional, you should research constantly, because wireless hackers will always try to guess the SSID, even if it's hidden. Okay, nothing difficult. They could have physical tools or software tools installed on a laptop. They could use it to capture all the information about SSID, like the one I just showed you right here. Okay. Now, you need to verify that your clients are not using SSID, the default name, because basically it could tell the hacker that your target access point is out of date. Now, configuring an access point varies because the interface here depends on the embedded operating system supplied by manufacturer. Like Linksys boxes has a different interface than TP-Link or D-Link or ASUS or whatever. Users can access the software through a web browser, because basically, the embedded OS supports web server, or also you could find the software downloaded through your mobile app as well. Now, accessing and reconfiguring access point router, like for example, the DD-WRT is straightforward. You could type the IP address in the web browser, provide the user login name and password. Most of this information, by the way, can be found on the back of your access point router, like Linksys or D-Link. You could find the IP address, the default IP address, the default username and a password. Once you enter the IP address and username and a password successfully, and correctly, you'll be able to access the status tab, and you can see the wireless interfaces and also the security option for you to change or modify. Now, if you look at this picture over here, for example, for the DDWRT.com, which is used in some Linksys box, here you can see that the name of the router, the model number, the firmware version of it, kernel version, also the MAC address, for how long it's been up, what type of CPU, and how much memory it has. Here you can see that the wireless mode, like if you want to access the actual wireless interface Ethernet, the access point is here. You can see this is access point. Okay, now here the wireless network mode, this is mixed. Okay, and by the way, the wireless network mode, it could be infrastructure mode, or it could be ad hoc mode, you know. And basically, you could have it in mixed mode. Okay. Now, when we say infrastructure mode, means that devices connect to an access point or router. If it's in ad hoc mode, means wireless devices connect directly to each other without having an access point in the middle here. And usually people leave it in the mixed mode. Now, when it comes to the channel bandwidth, here we could see it that at 20 megahertz. Now, the channel width, it defines the width of the radio frequency, like how much space in RF spectrum is being used for the channel. So the default one here on the screen is 20 megahertz, which is the standard one. It could be 40 megahertz, which was introduced in 802.11n. You know, and possibly you could see 80 megahertz and 160 megahertz, which helps to increase data rate. And in the latest Wi-Fi 7, you could see also the 320 megahertz, which is supported by the latest technology, which still right now it has not been used a lot or not being fully developed yet. Now, keep in mind that the wider the channel bandwidth, the wider is, the more data to be transmitted at the same time, which can improve the performance of the network. And here are the wireless channels. You could define the type of, the range of the channel you want. And here's the SSID. Okay. And do you want it to be broadcast or not? Okay. And if you want to go for advanced setting, you could simply choose yes, and then you will have additional options to, to configure. Now, and this screen here, the focus will be on wireless security. Okay, now here you can see different type of frequencies, authentication or security protocol for wireless network that was developed to replace the WEP protocol. Now here we have different type of WPA, personal and enterprise. The WPA provides much stronger encryption authentication than the older one, WAP, you know. And and basically here you could see that this is where you type your shared key, you know. If you click unmask, you'll be able to see what you entered, and here how often to renew the key here. And there's an option called disable EAPOL key retries. Um, you see, if when disabling, it means that the access point will not attempt to resend the extensible authentication protocol over LAN. That's what it stands for, by the way. Key message if it does not receive a response from the client, which is basically just a security feature to protect your network from the crack attack, which is a vulnerability in WPA2 protocol you know. And by the way, the crack attack stands for key reinstallation attack, which is a significant vulnerability in WPA2 here, which was discovered back in 2017. This is why you should use, if available, WPA3 because it provides much a lot of improvements over WPA2 here. Now, here we have the wireless network card. Of course, you need to have wireless network card connected to your computer, or I mean, all right now everything has a built-in wireless network card. And also, there are many things to consider when purchasing external wireless network card if you want, which one to purchase, what features you're looking for. And, basically, I prefer to choose very well-known vendors, known for their quality and support. Okay, so let's talk about wireless network standards. A standard means, there are a bunch of rules formulated by organization that you must follow it. Now, in this example here, we see that Institute of Electrical and Electronics Engineers, IEEE, they have their own standard. For example, like the maximum cable length in the Ethernet network, and they have their own rules for the wireless network. They have a working group, part of IEEE, are formed to design and develop new standards. For example, like, the project 802, which basically developed to create LAN and WAN standards. This working group, they assign numbers like 11 for wireless LAN group. As you see in this example, 802.11a or B, and we will talk about it more. Now, let's look at 802.11 standard. This is the first wireless network standard. Defines specification for wireless connectivity. It basically applies to the physical layer, and it uses something called carrier sense multiple access collision avoidance. Now, what does it mean? It works by having the devices listen to the medium before transmitting data. Now, if the medium is sensed to be idle, quiet, the device can transmit its data. However, if the medium is sensed to be busy, the device will delay its transmission and wait for random amount of time before trying again, which is completely different than used in the Ethernet, where, they're using collision detection. Now, the medium access control MAC protocol is not okay. It is used to control access to shared medium. Now, because radio signals can mix and cause potential signal collision. Now, the disadvantage of it is what? It's inefficient in networks with a lot of traffic and vulnerable to collisions. Now, however, the wireless LAN don't have an address associated with the physical location. Well, why? Because Wireless LAN uses radio waves to transmit data, and radio waves are not bound to any specific location. They have something called station, STA, addressable unit. Now, this STA can be a computer, smartphone, tablet, or any device that is connected to the wireless LAN. And each one of those STA has a unique identifier called the MAC address. Now, the 802.11 uses basic service set as its building block. The BSS, it's basically a collection of STAs that make up your wireless LAN. Like at home, we have different type of wireless devices. Basic service area, BSA, it's a unique identifier for the BSS. It's typically the MAC address of the access point serving the BSS, the basic service set, which basically, when you look at service area, means it is a coverage area, provided by the access point. There are two types. The one that's using infrastructure mode, which basically all communication in this type of BSS happens through the access point. If one wireless device wants to communicate with another in the same BSS, it sends the communication to the access point, and then the access point will relays it to the target that intended to receive the signal. In ad hoc network, an independent wireless LAN without an access point. There's no central access point, in other words. Temporary and used for very specific short-term needs. Now let's look at the extended service set. Here you can see a group of multiple interconnected BSS, and here you can see that BSS1 and BSS2, and you can see that they share the same SSID together, and each one of them, they have a different access point. Okay, and each access point, of course, they have a different MAC address here. Now, so basically, how this is going to benefit? It's going to benefit users to roam easily, seamlessly between different BSS. Like if you're moving from office to another office, okay, which basically makes it ideal for larger environment like campus or enterprise, where having only one single access point might not be enough. Now, keep in mind that all of these, the BSS 1 and 2 or 3 or 4 or whatever, they have to be connected to something called DS, which is basically the backbone network that connects multiple BSS, okay, in this extended service set environment here. You know, typically, each one of them is connected through a wired network. Now, as long as the station, by the way, you see it right here, okay, within its BSA basic service area, it can communicate with other stations on in the BSS. Okay, now now the most important design is that to have a DS right here. Okay, and it is recommended to have it in a wired network. Even though some others they say you can have it in a wireless, but I do not recommend this type of design. Now let's look at the basic architecture of 802.11. The IEEE specification defined the operating frequency range of 802.11, and this is the range for 2.4 gigahertz. Now, each frequency band contains channels. It basically this channel breaks up the bandwidth into smaller frequency ranges, and here you could see that this is 2.4 gigahertz frequency band with 20 megahertz channel bandwidth. Now, the 2.4, okay, basically gigahertz frequency now has a 14 discrete channels. You see, from 1 up to 14. Now, each one of them is 20 megahertz. However, you can only have four non-overlapping channels. You see that here, 1, 6, 11, and so on. Okay, and 14 also it can be added, you know. Now, this means no overlap, and you could see it here, the first one, the first channel, and the second channel. There is this, you know, it's not being used. That's to prevent interference. Now, instead of 2.4, I mean, let's say 5 gigahertz bandwidth is wider. It's between 150 megahertz range. This means that in case you set the channel bandwidth to 20 megahertz in the access point configuration, you will get 24 non-overlapping channels that you can use, which are free of interference. Now, the length of the sound wave is measured from the peak of one wave to the next, and it's referred to as wave length. It's typically denoted by the Greek letter lambda, you know, as you see in this picture here. The wavelength can be viewed using the oscilloscope, you know, which is a special hardware device. You can see these waves right here. Now, a sound wave, the sound wave's amplitude, the height, you see it right here, that's the height, okay, and the frequency determines its volume and pitch. Now, volume means the loudness of the sound, okay, and the pitch, basically the frequency determines the perceived pitch of the sound, which means like a higher frequency means a higher pitch. A lower frequency means lower pitch. Now here you can see that the frequency means the number of cycles a wave completes in 1 second. It measures in hertz. Now the cycle here, this is the cycle. This means the completion of repeating pattern of the sound waves here. Okay, and here you can see this is the wavelength. That's mean the completing of the pattern of sound waves here. And of course, here you can see the bands means, you know, you can have different frequency used by different technology to transmit the sound. Now here there are different frequency bands, the one I discussed it previously, and this table shows you the, you know, the frequency and the range and the wavelength of it. Now there's other wireless technologies. The infrared technology, very old. It's restricted to a single room or line of sight. You can find it in those cheap equipment, by the way. It cannot be seen by human eye, cannot penetrate walls, ceiling, or floors. Something is called the narrowband. It uses microwave radio band frequency to transmit data. Now, what's the advantage? It's it's very efficient in terms of power consumption, less susceptible to interference, and can travel longer distances. I mean, which is where there is a lot of environmental noises. Now, disadvantage can only transmit a limited amount of data, which means it's not suitable for application that requires high bandwidth, and commonly used in cordless phones, garage door openers. Now let's talk briefly about spread spectrum, which is a technique used to spread the signal over a wider frequency band into the carrier signal. Now, modulation means what? How the data is placed on the carrier signal. And like, you know, when it comes to modulation for the spread spectrum, the data is spread across a large frequency bandwidth instead of traveling just, you know, across just one frequency band. Now, there are many, many reasons behind doing this, you know. One of the reasons is that a narrowband interference source will only affect a small portion of the spread spectrum signal. And the spread spectrum uses different methods, like you see it here on the screen. You know, and methods basically refer to the specific technique or modulation, as you see it here. used to spread a signal across a broader frequency bandwidth than it is strictly necessary for the data it carries. I mean, these methods basically are designed to provide benefits like interference, resistance, better security, and improve signal quality. Now, there's additional IEEE 802.11 projects. The B one, it operates in 2.4 gigahertz band, very slow speed, allows for only 11 separate channels to prevent overlapping signals, which is 1, 6, and 11. And they introduce the wired equivalent privacy, the WEP, which is something we will talk about it later on. And we have the A standard, has a different frequency range, you know, from 11 and 802.11b. It uses 5 gigahertz range and it improved the speed to 54 megabit per second. The G standard operates in 2.4 gigahertz range. It uses different modulation, like the OFDM method, and increases the throughput to 54 megabit per second. The I standard, it introduces the WPA, protected access, and corrected many security vulnerabilities in the previous one, which is the B1. The E standard has improvement that address the problem of interference, you know. So what happened when interference happened, the signal basically jumped to another frequency more quickly. The N standard operates in the same frequency and uses the same encoding as the G, you know, uses multiple antennas and wider channel. And I'm sure you have seen this in the previous access point. We see multiple antennas out there, and the speed went up to 600 megabit per second. And you still see it in older type of access point routers. Now, the AC standard uses 5 gigahertz, and the speed goes up to 1 gigabit per second. The AD standard allows for transfer rates up to 7 gigabits per second over 2.4, 5, and 60 gigahertz bands. Now, the 802.11ah standard targets lower energy consumption. It can be used to extend the range of Wi-Fi networks. The AJ standard, this is a Chinese standard to maintain backward compatibility with 802.11ad. Technology use 45 gigahertz and 60 gigahertz spectrums, which is uniquely available in China. Now, the X standard start using the Wi-Fi 6, replaces the AC, and the speed, can go up to 10 giga, uses less power, more reliable in congested environment, and supports better security here. The 802.11 standard, okay, that's the one addresses networking devices in one person's workspace. That's why they call it WPAN, Personal Area Network. Bluetooth, it's a very good example. The 802.16 standard covers wireless metropolitan area networks, the MANs, okay, and has a limited distance available, and it's widely used implementation of wireless MAN technology. Okay. Now, the 802.20 standard is another MAN standard known as a mobile broadband wireless access. It addresses the wireless MANs for mobile users. You can see it in the subways, in trains, or cars at speed up to 150 miles per hour. And IBROS is very common implementation of the MBWA, the mobile broadband wireless access. Adaptation is very limited, and you can see it in some part of Africa and Asia. Now here you can see those Summary of approved wireless standard. You can see that the standard right here, the frequency used, the maximum rate it can go, and the type of modulation method, the one we discussed briefly before. And here's also more standard like AX standards, the WiMAX, the Bluetooth, and other type of frequency applies to each one of them, and the maximum rate, and so on. Now I want to talk about a very important topic, which is the 802.1x standard, which defines the process of authenticating and authorizing users on the network. This basically standard is it's a protocol that provides a network port-based access control. It serves as a framework for authenticating and controlling user traffic, based on their credentials and the authentication status of their device. We will go over some of the basic concepts, when you see it here on the screen: point-to-point protocol, extensible authentication protocol, WEP, WPA, and WPS. Now, the first one here, uh, many ISPs use PPP. It's based on data link layer. And basically, it facilitates bi-directional communication over serial connections, like telephone, cellular telephones, trunk lines, and even fiber optic links. Now, the other thing, it allows for dynamic assignment of IP addresses, reducing configuration overhead. It handles authentication by requiring a user to enter just username and a password, and then it verifies the user authentication, and the user attempting to use the link, who they are, who they say they are. Now, another important protocol is the Extensible Authentication Protocol, which is enhancement to PPP. Now, it is designed to allow a company to select its own authentication method. Unlike other type of protocols, you have to use very specific type of authentication method. And again, it works in a data link layers, basically, such as PPP or IEEE 802.1x, which is used either in wired and wireless LAN. The whole purpose here is that to transport authentication related information between the supplicant and the authentication server. Now, you could see it like in the radius server, you could see it in the VPN solutions. They all use this type of authentication protocol. Now, another example, like a company can use certificates or Kerberos authentication to authenticate a user connecting to access point here. Just briefly, we will go into certificate in a different video lecture. It's a record that authenticates network entities such as server or client. It has X509 information, which it has the owner identity, a certificate authority, and the owner's public key. And this is just a simple example of the X509 certificate. Now, there are many different methods, being implemented by the EAP. The first one's EAP TLS, which uses, the transport layer security, and it's based on certificate, and that's very important because it provides very strong security, but requires an excellent and very good public key infrastructure, PKI, which is something, again, we will discuss it in cryptography video lecture. Now, the TTLS is an extension to this one over here, which provides a secure channel. Only the server is authenticated using certificate, while the client authentication occurs inside a very secure tunnel, using other methods. Now, the PEAP, protected EAP, creates also a secure tunnel between the supplicant and the authentication server. Now, it's like the TTLS, only the server is authenticated with a certificate initially. Now, just to know that the TLS and the TTLS and the protected EAP require a radius server, like for example, like the free radius or the Microsoft NPS, and require very good PKI infrastructure for certificate issuance, and also any network devices, such as wireless access point that support 802.1x. Now, the EAP Fast, this is developed by Cisco, and also it uses secure tunnel and support various authentication method with it. Like, which basically concerning this, it requires also a radio server, preferably by Cisco, the ACS, which stands for Secure Access Control System, or ISE, Identity Service Engine, used to manage endpoint, user, and device access to all the network resources within a zero trust architecture. And now, by the way, if you're not familiar with what does it mean by the zero trust architecture, it is basically a security framework that assumes no user or device is inherently trusted, even if they are inside the corporate network, because this type of architecture relies on strong authentication, least privilege, micro-segmentation, and most important, also continuous monitoring of the network. And the last one is the EAP MD5, which uses the MD5 hashing algorithm for challenge response authentication. It's considered less secure and rarely used. Now, it's very important to understand how this process works here. And here you could see the three major components: the supplicant, which is the one attempts to be authenticated by radio server right here. And this one is the authenticator. Authenticator could be an entity like a wireless access point or a switch that basically acts like a gatekeeper, either allows or block data flow based on authentication status coming from the supplicant. You know, think about it, it's more like a pass-through for APA packet, as you see it right here. All the packets is just passed through for APA messages between the supplicant and the radius server or the authentication server. And here finally, here you could see the radius server, which is, it could be radius, authentication server. It could be a radius or diameter server. This server basically performs the authentication based on the message received from the supplicant through the AP. Now, let's talk about the wired equivalent privacy, which is part of a very old, wireless standard here, the B standard. It's developed to encrypt data traveling, or in the wireless network. The WP encryption is easily cracked. Why? Well, simply due to a flaw in RC4 encryption algorithm. It uses two types of primary keys, the 64-bit and 128-bit key. Both are vulnerable to attacks. Now, it is easy to crack. In fact, I've done it before in a testing environment. I was able to crack, the WEP key easily using AirCrack in Kali Linux, due to the fact is that it uses weak IVs. Now, if you're not familiar with IV is initialization vector, which is a random or pseudo-random number that is used with the secret key to encrypt data. The IV purpose is to ensure that the same data encrypted with the same key will not always result in the same cipher text here. Now, the fact is the implementation of IV in WEP, it's a small size space. and gets reused, which is makes it so easy once you gather enough amount of information to crack it. There are many WEP implementation uses predictable IV sequence, which makes it even worse for security and easier for attackers to collect IVs and break into encryption simply by using, again, like I said, aircrack in Kali Linux. It uses CRC-32 checksum as an integrity check value ICV, which is not strong in protection. Also, the other issue is inadequate standardized key management because, you know, the problem here, whether the users or the network administrators, they rarely change the setup or the key. Now, here we have WPA, WPA2, and WPA3. This is part of 11i standard. It's a replacement for WEP without requiring new hardware. And that's important. Now, it improves encryption by using temporal key integrity protocol, TKIP enhancement. Now, these are basically the enhancement you see that addresses encryption vulnerabilities in WEP. The first one is the message integrity check, MIC, which basically to ensure data integrity and guard against, forgery attacks. And the extended initialization vector IV with the sequencing rules. Basically, this is combined with the sequence rules to counteract replay attacks, makes it difficult. Pair pocket key mixing feature that complicates efforts, to crack the encryption by altering the key for each pocket, and that's what makes it difficult. A rekeying mechanism that frequently change encryption keys to limit exposure time. And finally, it can be integrated with those authentication method, the one we discussed previously. Now let's focus a little bit more on the WPA3, which was introduced back in January 2018 to replace WPA2 and provide better security features. For encryption, it uses AES 256, which is very strong encryption, and uses SHA 384 for integrity. This is also very good. And WPA3 enterprise mode. Now, if you're asking what's the difference between enterprise mode versus personal mode, simply think about it this way. The WPA3 personal, is uses authentication method by relying on a pre-shared key, PSK, which is typically the one, we use, which is the passphrase that is known to you and to members of your family and also like to the network administrator. Why? Because it is simplified setup, and therefore it is primarily designed for home and very small office environment that does not need a complex setup or centralized authentication. On the other hand, the enterprise mode, it relies on centralized authentication server, like the one we discussed, 802.1x framework. The clients are authenticated either using certificate or their user credentials or both together, you know. Also, it is designed for corporate or any large scale networks where there are so many users and it's required enhanced and strong security implementation there. Now, it mandates the use of CCMP 123, 128, which is AES 128 in CCM mode as a minimum encryption algorithm in WPA3, the personal mode. It uses simultaneous authentication of equals, SAE exchange. Okay. Now, which is basically, think about it, it's a password authenticated key exchange protocol that results in more secure initial key exchange, which is extremely important. Now, it is difficult for hackers to tap into network using offline password guessing attacks because of this type of implementation used. However, it might be susceptible to timing attacks during handshake process if there's enough information gathered that can be used for for password cracking. Now, basically here, uh, the authentication method, or sorry, or the timing attack is an attack in which the attacker attempts to compromise the crypto system by analyzing the time taken to execute, the algorithms. Like, because every operation in a computer takes time, and the time can vary based on the input and the process. Now, 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 here's the thing: if the attacker can measure these timing difference correctly, they can gain insights on the, or idea about the data being processed. Now, however, the implementation technique of WPA3 makes it much more difficult for attacker to launch this successful attack. But I mean, it's still possible if the attacker have access to a large amount of data that has been encrypted with the same key. Now, the question was there any few successful timing attacks against the BOPA3? Well, in 2019, researchers discovered a timing attack against it, which was against a drag-on-fly handshake protocol. Now, this attack could be used to recover the encryption key if the attacker had access to a, again, very large amount of data that had been encrypted with the same key. See, that's the issue. And also, another researchers from Roher University and some other semiconductor company discovered timing attack in 2020. Now, the good news is that these attacks were mitigated by software updates from the Wi-Fi Alliance. Now, the Wi-Fi protected setup, we all see it at home. Like if you look in the back of your access point, you will see the small switch here or button here, uh, which is a wireless authentication standard created to allow users to add devices easily and securely, supposedly securely, to wireless network. Now, it makes it easy and simple for user to add any device, any wireless devices to their own network. They just have to press the WPS in the router here and the one in the device and wait for them to authenticate each other. However, a flaw discovered back in 2011, which allows attacker to gain access to a network remotely, without knowing the WPA2 password. That's, you know, I mean, the main vulnerability is basically associated with WPS, using the PIN method. Now, due to this vulnerability, and even though to this type of implementation, many security professionals advise disabling WPS in router setting, especially the PIN feature here. Some new routers right now, they have implemented a lockout feature after a certain number of failed attempts to counteract this type of what is called the brute force attacks. But however, the safest approach remains is turn it off. Now let's try to understand what is word driving. This word driving technique it used also, by hackers. When they drive around, when expensive hardware, software, as you see in this picture, they try to pick up any weak access point nearby, you know, or unsecured access point. By itself, it's not illegal, but if you exploited one of those wireless network here, then this becomes illegal. Now, how it works, very simple. You need a Wi-Fi capable laptop with the software that scan area. You need a wireless network card, and keep in mind that not all of them are compatible with the scanning software you want to use. So make sure that it works with this with the scanning software. Now, antenna prices vary depending on the quality and the range. And most of these software, basically, they could pick up the SSID, even if it's hidden, security type in, used, and the signal strength. Now, a very good example is the Vice Tumbler. It's a freeware tool written for Windows that enable wireless LAN detection for all these Wi-Fi standards here. Easy to install. The primary design to assist pen testers in verifying the wireless LAN configuration, detect that might be some other wireless networks might interfering with the wireless LAN and causing it to slow down, for example. Detect unauthorized access point in your corporate or in your area. And also it can be connecting to a GPS, basically to map location of all wireless LAN. The software detect like you see it in this picture over here. Now, the things that it can identify, for example, like you see here, the SSID, here's the SSID, the MAC address, here's the MAC address, the manufacturer, like in some cases you might be able to see the manufacturer company of it, the channel, and here you see the channel right here, the signal strength, it's over here. Okay. And what type of encryption they're using? Here's the encryption, type of encryption discussed before. Basically, attacker can detect access point even within 350-foot radius. But with the better antennas, they can go up to 2 miles. Now, the range of detection, is influenced by the type and the quality of antennas, by the way. The default one that come standard are omnidirectional antennas that radiate signals in all directions. They're good for general purpose detection, but they're limited in range. Now, the other one is called high gain antennas. They can amplify the signal strength, by increasing the detection range, and they are omnidirectional, and it could be directional antennas now. Oh, so what is directional antennas? These can point in specific directions to detect access point from greater distances. Sometimes like couple of kilometers or miles away or more, depending on the line of sight and environmental condition here. Now, uh, Casmet is also can be used for doing word driving attacks and runs on different type of operating system. It's a sniffer, an IDS. It can sniff all these type of traffic coming from these Wi-Fi standards here. It features Wireshark and TCP dump compatible data logging. It's also compatible with AirSnow and AirCrack, and has network IP range detection and can detect hidden SSID. So, it has very nice graphical mapping of networks. It also can give you the manufacturer and the model, identification of the access point on the clients. It also can give you output in XML format and support many, many different of wireless card types. Now, understanding wireless hacking. I mean, hacking a wireless network is not much different from wired LAN. You still have to do port scanning, you still have to do enumeration tools. All the stuff was discussed in other video lectures. Now, what do I need to do? Obviously, you need a laptop. Makes it easy for you to take it anywhere. You need a wireless network card. You could use the internal one, preferably the external one with a very good antenna and a sniffer software. And there are many, many tools for cracking WP or WPA keys. For example, the ACrack-NG. Now, the AirCrack-NG, it focus on different areas of with Wi-Fi security. And if you go into Kali Linux and you type help, you see a lot of common options here you could use, you know. And what does it do, related to Wi-Fi security? It does monitoring because it can capture packets and export it to a files, so it can be used by third party for analysis purposes. For attacking, it can replay attacks, de-authentication. It can create fake access point, and it can do packet injection. Also, it's good for doing testing, like checking different Wi-Fi cars, other driver capabilities, and for cracking these type of uh, Wi-Fi authentication. Now, uh, the key components of AirCrack Suite are, the first one is the AirDump NG, which is it's a packet capture utility that sniffs wireless packet and save it into a file. It can display all the detected wireless networks in the area with important information related to the SSID, channels, encryption types, and signal strength. And that's basically the first step you need to do in Wi-Fi cracking. You need to capture as much as possible of the wireless packets here. Then, in order for you to increase the traffic and to capture even more and more data, you need to use the air replay attack, which is used to inject the frames into wireless network. Uh, it's often employed to generate traffic for capture, especially if you want to crack, web WP, sorry, encryption. Now, the main tool, after you finish with those two steps here, this is the main tool, the ACRAC NG. It's mainly for cracking, whatever you captured here. It analyzes the capture packet, attempts to recover the network password. It can employ multiple type of attacking techniques, including dictionary attacks, brute force, and statistical base attacks here. Now, there's another tool. It's called Airbase NG. That's a tool for setting up rogue access point, useful for man-in-the-middle attacks, by the way. Now, there's another great and useful tool. It's called Fern Wi-Fi Cracker. It's a graphical user interface based tool designed for wireless security auditing and pen testing. It's developed using Python, and the whole purpose is what? To simplify the process of wireless network analysis and attacks. It's very easy to use, and you will like it if you try it. Now, what are the countermeasures for wireless attacks? Uh, consider using anti-aware driving software. It makes it difficult for attackers. You could use measures for preventing radio waves from leaving or entering the building, like use certain paint on the walls to prevent radio waves from escaping, you know. And also, you could allow only the approved MAC addresses to access your network, which is, I find it, it works, but it is difficult task to do, especially if you have a lot of wireless networks at home or, of course, at the corporate level, Consider using authentication server to authenticate and especially deploy EAP, which allows you to use different protocols that enhance security, which we discussed this previously. Now consider placing the access point in a decentralized zone like DMZ. Like you should have a firewall at the front of the internal network, basically to block and filter out the traffic from an unauthorized IP address. And then, of course, you have to place the access point, after the firewall. You should upgrade your authentication to WPA2 or at least WPA3. Okay. And if the hardware does not support it, like if you're still using a very, very old access point, then I would strongly recommend dump it and buy a new one. Now, assign static IP addresses to wireless client instead of DHCP. Well, good luck with this, especially if you have a lot of gadgets at home a lot of wireless devices at home. It is very difficult to do this. I mean, the only thing I could recommend using static IP address, like for wireless printer, or like if you have my cloud device that do backup, or or server. For example, yes, I do support static IP addresses. Now, disable WPS, we discussed this before, and then you could change the default SSID and disable SSID broadcast. Now, if you cannot disable it, rename it. Now, okay, just keep in mind that while the SSID is not actively broadcasted, it's still present in the association frames and other packet types, so which means anybody with the skills, you could use tools like ACRAC or CASMET or Wireshark. You can easily detect those hidden networks. It is only good disabling the broadcast just for casual users. Finally, by the end of this video lecture, you should be able to explain the wireless technology, describe wireless networking standards, describe the process of authentication, describe where driving, describe wireless hacking and tools used by hackers and wireless professionals. And I just want to thank you so much for watching this video lecture. I hope you find it useful. Take care.